Okay, so we've already talked about using four rectangles to estimate the area under this curve. So let me just remind you what area we're talking about. It's this area right here. And we already also talked about how to find the width of each rectangle. We have it here, and the height of each rectangle. So let's just write that out again real quick. So the width of each rectangle is 1/4. It was the total length of the interval, which was just 1 divided by the number of rectangles, which is 4. And then the heights, we said, were just the f of the x values. So in other words, we had f of 1/4 was the height of the first rectangle. F of 2/4 was the height of the second. So let me make a list here. You'll see why in a second. I'm going to take the time to do this. So f of 1/4 was the height of the first rectangle. F of 2/4 was the height of the 2/4 was the height of the second rectangle. F of 3/4. I know that this is boring to watch me write these out, but I'm going to just finish real quick here. F of 4/4, or in other words, f of 1. It's the same thing, right? These were the heights of the four rectangles. Okay, now there's something real quick I want to sidetrack us on, and it's not really a sidetrack, but just let's take a look at it. If I were to write out a list of numbers that looked something like this, if I said 2, 4, 6, 8, so on and so on. So it goes on like this indefinitely. And I said, okay, well, obviously this is the first term. This is the first term. This is the second term. This is the third term. This is the fourth term. If I asked you for the fifth term, what is it? What's the very next term? Well, you're just so smart that you know instantly this is 10. You probably don't even, you might not even know exactly how you know that. It's just, you're going up by 2 every time, right? But, well, what if I asked you to find the 30th term? Would you know exactly what it was? Well, hopefully you would, because isn't this just, the first term is 2 times 1. The second term is 2 times the 2. So 2 times you can think of the second term 2 times 2. The third term is 2 times 3. The fourth term is 2 times 4. So the 30th term this is just equal to 2 times 30, which is equal to 60. The 15th term, well, that's just 2 times 15 is equal to 30. What about the ith term? So what do I mean the ith term? Well, any term. It could be the first, it could be the 102nd. It could be any number you choose. Is there a formula that based on its position you could figure out exactly the number it is? And yeah, of course, it's 2 times I. And verify that you really understand that. Make sure you understand that. If I is 1, the first term, then it's just 2 times 1. Well, that makes sense. The first term is 2. If I is 4, this fourth term, well, it's 2 times 4. It's 8. So you get this. So the formula for finding any term, if you want the 1000th term, or let's say the 1001 term, then it's just 2 times 1001, or in other words, it's 2002. So we can find any term in this list by this formula, 2 times I. Okay, I know I'm belaboring the point, but that's actually the hardest part about doing Riemann sums, or Riemann sums, which is what we're doing, which is what we'll start talking about doing. So it's really that understanding that is really, in my opinion, the hardest part, and it's not too difficult. So here, if we want the ith height, what's our formula going to be? The ith height. So the height of any rectangle. That means if I give you I as 2, the second rectangle, you better find a formula that spits out f of 2/4. Well, it's just going to be f of I over 4. Because when you want the first rectangle, you have 1 over 4. So the first rectangle, I as 1, you get 1 over 4. When you want the second rectangle, you get I as 2, and you have 2 over 4. 2 over 4, you can see it works for the third rectangle and the fourth rectangle. So this makes sense as a formula. If you want whatever rectangle it is, if it's the ith rectangle, this is how you figure out what the height is. Really make sure you understand that. I know that I'm stressing this a lot and kind of belaboring this point, and for those of you that get it, I apologize. But make sure that you understand this before you move on, because that's really the key to solving all of these problems, is just figuring out what the height is. the height of the ith rectangle. Anyways, let's move forward. Okay, so now we're going to tie these two things together, and we're going to want to sum up as I goes from 1 to 4. Well, what are we summing? We want to sum the area of all the rectangles. So we sum up the area of the area of the ith rectangle. What does that mean? Well, if I is going to be 1, then we take the area of the first rectangle. Then we add to it, when I is 2, the area of the second rectangle, and so on and so on. So this is just equal to the sum as I goes from 1 to 4 of f of I over 4, the height of the ith rectangle, times the width of the ith rectangle. Well, the width of every rectangle is the same, so it's just a constant. Hence the term constant. It doesn't change. It's the same always. So it's just f of I over 4 times 1 over 4. And this will truly add up the area of the 4 rectangles. Because you plug in 1 for I, and you get f of I 1 over 4, and that's the height of the first rectangle, times the width of the first rectangle. Well, that's the area of the first rectangle, so then you're done. Then you add to that when I is 2. Well, that's the height of the second rectangle times the width. That's the area of the second rectangle. And you do that 4 times, you're going to get the area of all 4 rectangles. And that is the key to all of this. But now let's move forward. The rest is just the algebra of sums, really. So we're going to simplify this. So I didn't give us a function yet. Let's say the function is x squared plus 1. Well, now we can just plug in I over 4 into x squared plus 1, right? It's f of I over 4. So this is the sum as I goes from 1 to 4. F of I over 4 is just going to be I over 4 goes in for all the x's we have. So that's I over 4 squared, because we have x squared, plus 1, times by the width. So this is still height times width. The height is just the f of x value. So the height times the width, and now we can evaluate this sum. And I hope I have time to do so. I don't really want to rush it. This might drag on to another video. But anyways, as I goes from 1 to 4, so let me do 2 steps in once. This is going to become I squared over 64 plus 1/4. So what I did is I just squared this, and then I distributed the 1/4 inside. And if you watched the last video, you know that this sum can be broken into 2 sums. I'll show you what I mean. I squared over 64 plus the sum as I goes from 1 to 4 of 1/4. And now we can simplify things a little bit by pulling that 1 over 64 out. So that's just pulling out a scalar multiple. Oops. So this is I equals 1, or goes from 1 to 4 of I squared plus the sum as I goes from 1 to 4 of just 1/4. And now there's not too much left to do. Let's remind ourselves, what's the sum of I squared? So the sum as I goes from 1 to n of I squared is equal to n times n plus 1 times 2n plus 1. So this is something you're going to want to know come test time, that formula, over 6. And so instead of n's, we have 4's. So this becomes 1 over 64 times by, well, it's n, so that's 4, times n plus 1, that's 5, times 2n, that's 8, plus 1, that's 9, all over 6. And then the sum of a constant is just the number up here times the constant. So this is 4 times 1/4, which is just plus 1. So this is plus 1. And I'm running out of time, but this simplifies to become 30. A good way to see that is you could just take a 2 out of here, a 2 out of here, so this is 3. Then a 3 out of here and a 3 out of here, that's 1 and that's 3. And you have 2 times 3, that's 6, times 5 is 30. So this is 30 over 64 plus 1, which becomes 94 over 64. And that's our estimate for the area using 4 rectangles. So using these 4 rectangles, that's our exact estimate. It sounds silly, an exact estimate. Anyways, I hope this video was helpful. We'll talk about finding the exact area of this region in the next video. See you then.